In this video, we will explore the fascinating world of linked list, which is one of the most versatile and widely used data structures in computer programming. A linked list is a collection of interconnected nodes where each node contains a value and a reference to the next node in a list. And this structure makes linked list highly dynamic, allowing for efficient insertion and deletion of elements at any position in the list. So we'll break down the concept of linked list in simple technical terms, and we'll provide a simple real life example to help you visualize and understand the structures. So let's get started with what is a linked list. Basically, linked list is a data structure that stores a sequence of elements where each element is a node. Now each node contains a value and a reference to the next node in the sequence, and this allows for easy insertion and deletion of elements in the middle of the list, unlike an array where element needs to be shifted to make a room for new elements. Basically, a linked list is made up of nodes, and each node contains a value and a reference to the next node in the list. The first node is called the head and the last node is called the tail. Linked lists are useful when you need to frequently add or remove elements from the middle of a list. And they are useful when you need to traverse the list in both directions, be it forward or backward. It's worth noting that linked list is a dynamic data structure, meaning the size of the list can grow or shrink as the elements are added or removed. Linked lists are commonly implemented using a doubly linked list, where each node has a reference to the previous node in the list. And this allows for a fast traversal in both directions, but also increase the memory usage per node. So to summarize this, we can say linked list is a dynamic data structure that stores a sequence of elements where each element is a node. It's useful when you need to frequently add or remove elements from the middle of list, and it's commonly implemented using a doubly linked list. Now let's understand it using a simple example. And a simple real life example of a linked list could be a shopping list. So imagine you have a piece of paper with a list of items you need to buy, and you are adding and removing items from the list as you go. So at the top of the paper you write shopping list. Underneath you write the first item milk. Then you write the next item bread. Below that you write eggs. Now this is a simple linked list. The first element milk is the head. The last element eggs is the tail. Now each element is a node and it has a value, that is the name of the item, and a reference to the next item in the list, that is the item below it. So when you are at store and you realize you don't need eggs anymore, you can simply cross it out or remove it from the list. This is equivalent to removing an element from the linked list. And if you remember you need to buy cookies, you can add it to the list. You can write it below the eggs and make a reference from the last item eggs to the new items cookies. And this is equivalent to adding an element to the linked list. This is a simple example that illustrates how a linked list can be used to store a sequence of elements and allows for easy insertion and deletion of elements. So let's understand it better using a simple Python code, and that describes a linked list from the scratch, and it can work well on the Google Colab. Basically, this code defines two classes, node and linked list. Here, the node class represents a single node in the linked list. It has a value attribute and a next attribute, which is a reference to the next node in the list. Here, the linked list class represents the linked list itself. It has a head attribute, which is the first node in the list. The add node method is used to add a new node to the beginning of the list. It takes a value as an argument and create a new node with that value. Here the new node's next attribute is set to the current head of the list, and the head is updated to point to the next node. Then comes remove node method, which is used to remove a node from the list. It takes a value as an argument and searches the list for a node with that value. If a node with a given value is found, it removes that node from the list. It returns true if the node was removed, otherwise it says false. Then comes print list. Now this method is used to print the elements of the list. It starts from the head of the list and prints the value of each node until the last node. You can use this code in a Google Colab by running the code in a code cell, and then you can use a linked list class to create and manipulate a linked list. Please note that this is a simple implementation. There are other ways also to implement linked list in Python, and this implementation does not include all the features that you might need, but this should give you a good starting point. Thank you.